Hello, in this tutorial we are going to learn how to count the elements of an array using the cpplinq library. As target board I'm going to be using an ESP32 Firebittle board from DFRobot. So for this simple example we are going to make a bit more interesting and to see the usefulness of this count operator, we are going to check two use cases. One of them we are going to chain the count operator with the where operator. So basically first do a filtering to an array to get all the elements that fill a specific criteria, and then we count the number of those elements. And the other use case will be basically checking an overloaded version of the count operator that pretty much allows us to specify also a filtering condition as input. So basically the second version that we are going to use is pretty much the same as chaining the where operator with the count operator, but merged in a single call. But we'll see this in more detail as we jump into the code. So the first thing we are going to do is including the cpplinq library, so we can have access to all the operators we need, and then we are going to declare the using of the cpplinq namespace like we have been doing before. Then in the Arduino setup function, we start by opening a serial connection, and then we are going to define an array of integers with a couple of values. So in order to specify or to indicate what is going to be our filtering condition for the where operator, basically we are going to obtain all the elements that are lesser than 100, and then we want to count how many elements are lesser than 100. So to know what is the expected result, we can see here that we have 3 elements that are lesser than 100. So after applying both the filtering and the counting, this is what we expect to obtain. And then we are going to look into our expression trees right away. So the first thing we need to do, like before, is converting our integer array to a range object, because only after that we can start applying cpplinq operators, and then and we can do this with the call to this from array function, like we have seen in countless other tutorials. Then we just need to apply in this first scenario the where operator, so we can filter all the elements that are lesser than 100. Pretty much like we've been doing before, we are specifying this as this filtering condition is passed as a function that is passed as input of the where operator, and we are specifying this filtering function using the C++ lambda syntax. Basically it is an anonymous function, and this function will be applied by each element of our range, and it should return true if that element fills our criteria, or false otherwise. As you can see here from the syntax, basically this function receives as input an integer because it will be applied by each element of the range, and each element is an integer, and in its body it is returning true if that element is lesser than 100, and it is returning false otherwise. So basically this is what we have covered before in other tutorials. Actually we have already seen this condition in other tutorial, but pretty much what we have seen with the where operator. Then, like we also covered in other tutorials, so this where operator will return a new range object with all the elements that fill the criteria, and then in order for us to keep applying more C++ operators, we use here this operator. This is overloaded by the cpplinq library, because obviously this operator, if we use it in another context, has other meaning, but basically in the context of the cpplinq, it allows us to chain new cpplinq operators to be called over the resulting range of a previous call. So basically this where returns a range. This where operator here, we use this operator to indicate that we want to apply a new cpplinq operator, and then in our case we are going to call to use this count operator, which, when it doesn't have any parameter, basically will return the number of elements that the range contains. This is it, very simple, no need to pass anything as input. In this format it will do that. So basically by chaining the two operators together, the filtering one and the counting one will end up here with an integer result that pretty much contains all the elements of our original array, the count of all the elements of original array that are lesser than 100, and like we have seen before, it should match the value 3. Naturally this is an integer. But as I've said before, there is another way for us to apply this operator in a much more compact way. Basically, our expression tree will be much simpler because we'll just need to apply the count operator. Okay, so let's start by the beginning. As before, we convert our array to a range object with the call to this from array function, and then we call the count operator. But instead of what we did before, this time we are going to pass as input a function, okay? And this function serves exactly the same purpose that it would serve on a where condition. It basically says that only the elements that fill our filtering criteria will be counted, okay? So basically, this function will be applied for each element. If it returns true, that element will be counted. Okay, it will increment the counter that will result from the count operator call. If it returns false, that element won't be considered for our counter. The filtering function is precisely and exactly the same we used before in the where operator, because basically we want to achieve the same result. The only difference is that we don't want to get the actual elements, okay? Because when we apply the where operator, we get a new range with all the elements that fill that filtering criteria. Whereas if we are using the count operator, instead we get the count of all the elements that fill that filtering criteria. So these are two ways of achieving the same result. These are two options. Depending on each person, will probably prefer a more verbose one like this, which is a bit more explicit, or maybe this one, which is less verbose, but maybe it doesn't show so clearly what are the steps involved. Anyway, for people that know the library and the basic operators, I think both approaches are fine. That's it. Very simple, two ways of achieving the same result, and then obviously we are going to print it to the serial port so we can get it on the Arduino with the serial monitor. So as usual, I've already uploaded the code to my ESP32, so we don't have to wait for the uploading procedure. I'm going to run it again, and as you can see here, we have obtained in both cases the result 3, which means that there are 3 elements that are lesser than 100 in our original array, and both approaches yield the same result as expected. So this is it. Thank you very much for watching. Hope you have enjoyed.